Our next example, what we want to do is convert degree, minutes, and seconds into just degrees. For our example here, we have 74 degrees, 12 minutes, and 18 seconds. Let's see what they want us to do. We want to round the answer to the nearest thousandths of a degree. So we're going to follow this procedure. We have 74 degrees, 12 minutes, and 18 seconds. 74 degrees is already in the format that we want. 12 minutes, what we're going to do is take the 12 and divide by 60. And we're going to take the seconds and take 18 and divide by 3600. That'll convert them into decimals. When we put those into a calculator, we're going to get 74 degrees plus 12 divided by 60 is 0.2, 18 divided by 3600 is 0.005. Combining that expression, what we get is 74.205 degrees. This is similar to the problem we just completed. Please press pause on the player and complete the problem on your own. When you're ready, continue on and follow along with the completion of this problem to make sure you have it correct. Let's continue. 124 degrees plus 51 minutes divided by 60 plus 9 seconds divided by 3600. Let's use a calculator to get our decimals. 51 minutes divided by 60 and 9 seconds divided by 3600. Those are our decimal values. Let's continue on. 124 degrees plus 0.85 plus 0.0025. Combining that expression, 124.8525. But with the last problem, they want us to round to the nearest thousandths, which would give us 124.853 degrees. Our next situation asks us to convert degrees to degrees, minutes, seconds. So here what you have is an example of a decimal value in degree, and they want us to actually take that back to degrees, minutes, seconds. Let's take a look at this example. In this situation, we're going to take 34.624 degrees, and we're going to separate the whole number into 34 degrees plus 0.624. Let's start converting. We want to take that decimal and multiply it by 60. That'll convert that into minutes. When we multiply, that's going to give us 34 degrees plus 37.44 minutes. We're going to pull off the whole number, which now gives us 34 degrees plus 37 minutes plus 0.44 minutes. But now we want to convert the 0.44 minutes into a second. So we're going to multiply that by 60 again. So now we'll have 34 degrees plus 37 minutes plus 0.44 times 60, giving us our final expression, which is 34 degrees plus 37 minutes plus 26.4 seconds. We combine that expression to get our answer, which is 34 degrees plus 37 minutes plus 26.4 seconds. We're going to round our seconds to the nearest tenth. What I'd like to do again is have you pause the tape, complete this problem, and when you're done, please press play and follow along to make sure that we have the answer, you have the answer correct. All right, let's give this a shot. So we're going to separate this. 36 degrees plus 0.0854. Let's convert that into minutes. So this will give us 36 degrees plus 0.0854 times 60. Using our calculator, 0.0854 times 60. That will give us 5.124 minutes. 36 degrees plus 5.124 minutes. Let's pull off the whole number again. 36 degrees plus 5 minutes plus 0.124 minutes. Now what we want to do is convert that into seconds. So we'll multiply that by 60 again. Using our calculator, 0.124 times 60. And that'll give us 7.44. 36 degrees plus 5 minutes plus 7.44 seconds. Let's round that, combine the expression and round it to the nearest tenth. And our solution will be 36 degrees, 5 minutes, and 7.4 seconds when we round it to the nearest tenth. Let's continue with some more vocabulary. An angle is in standard position if its vertex is at the origin and its initial side is along the positive x-axis. The diagram demonstrates that exact situation. The vertex is at the origin of a coordinate plane. The initial side is along the x-axis. The terminal side can sweep either clockwise or counterclockwise. An angle in standard position having their terminal sides along the x-axis or y-axis, such as the angles with the measure 90 degrees, 180, 270, and so on, are called the quadrant angles. Each of the diagrams below shows a quadrant angle. The first one is at 90 degrees, 180 degrees for the second one, and 270 degrees for the third. Each of those are quadrant angles. A complete rotation of a ray results in an angle measuring 360 degrees. So, in a coordinate plane, if I have an initial side on the x-axis, and we take one complete counterclockwise rotation, that rotation will result in a 360-degree angle. It follows that if I continue the rotation, that I would get angles that are greater than 360 degrees. And they could actually fall on top of themselves. For example, in the first diagram right here, I have a 60-degree angle from our initial side. Then what they did was decide to take another rotation, which would be 360 from the initial side, and then go another 60 degrees, which adds into a 420-degree angle. A 420-degree angle and a 60-degree angle represent the same terminal side of the angle. Therefore, when you have angles that represent the same terminal side, those angles are called coterminal angles. In this situation, when my initial side is on the x-axis, and my terminal side is either at 60 degrees or 420 degrees, those are called coterminal angles. The second diagram represents another example. In this situation, they have the initial side on the x-axis. They then made an angle that had a terminal side at 110 degrees. Then they wanted to show you can go multiple rotations. They did one rotation, which would be 360 degrees. The second rotation, another 360, which would give you 720 degrees. But here they continued to the terminal side of 110 degrees, so 720 plus 110 gives you 830 degrees. So your coterminal angles in this situation at 110 degrees and 830 represent terminal sides, common terminal sides. Therefore, those are coterminal angles. Let's take a look at an example. In this situation, they're asking us to find the angles of smallest possible positive measure coterminal with each of the given angles. Down below you have a bullet point, and this shows you the procedure of how they want you to find the coterminal angles. You can either add or subtract 360 as many times as needed to obtain an angle with the measure greater than 0 but less than 360 degrees. Let's take a look at the solution. For the first problem, 1,115 degrees, what they did was subtract 360 degrees, but in this situation they had to subtract 3 revolutions. That is represented by the 3 multiplying 360. When you do that, 1,001 115 minus 3 times 360, you're going to end up with 35 degrees. This angle is between 0 degrees and 360 degrees. The next one, even though this is a negative angle, we still want to end up with a coterminal angle that is between 0 and 360, but also positive. So what they did here was add a revolution. When they added a revolution, that gave them a coterminal angle to negative 187 of 173 degrees. That completes section 1.1, and here's the assignment that I'd like you to complete.